Bright Duty. Every student matters.
My name is Amit Ajmani, and in this video lecture we will see the Newton's second law of motion. Now, in the first law of motion, students, you have just understood and studied that when an unbalanced external force acts on an object, then its velocity changes. That is, the object gets an acceleration, right? But there are certain observations that we have seen in our day-to-day life. For example, let us take the first observation. In the game of table tennis, we have seen that if that table tennis or that ping pong, that we call it to be ping pong ball, that ping pong ball, the table tennis ball hits a player, it does not hurt him. But on the other hand, when a fast moving cricket ball hits a spectator, it may hurt him. Why is it so? So somewhere somehow we are able to correlate that, sir, the ping pong ball is quite light, right? It's light weighted, so that is that is why it is not causing any kind of injury to that particular person. And the cricket ball is dense, it's heavier. Of course you are right. So the reason lies behind this particular logic is the mass. Fine. So the mass is the factor that is basically depending upon the mass which is causing injury. Now let us take a second hypothetical situation. In our day-to-day life, we see that a truck standing on one of the sides of the road, it is at rest. Now it is standing there, it is not causing any kind of harm or injury or risk to anyone. So it is just parked along a roadside, it does not require any attention. But if the truck is moving, even if it is moving at a very small speed as low as 5 meter per second, it may kill a person standing in its path. It is going to cause severe injury. Now the truck, it was the same truck having the same mass, but now the difference lies in the speed. Initially the truck was at rest, and in the second case the truck was in motion. Similarly, we see that a small mass such as a bullet, even that may kill a person when fired from a gun. Right. So it is not only the mass, but it is the velocity also which is coming into play. So based on these observations, we see that the impact produced by the objects depend on their mass and velocity. Correct? Similarly, if we want to increase the speed of a particular object, we want to provide some acceleration to the object, we'll be applying some force on it. Now we know that if we want to achieve greater velocity, we need to provide or apply greater force. Fine. So therefore, based on all these observations, we conclude that there is some quantity of importance that combines the object's mass and velocity. And this quantity was suggested and introduced by Newton, and this quantity or this property is called momentum. Now, what exactly is momentum? Let us try to relate. The momentum is defined as the product of the mass and the velocity of a particular object. Now, this momentum is represented by small alphabet p, right? So, mathematically, we can write that p or momentum is equal to the product of mass and velocity. Now, if we are given the initial velocity of the object, right? So, we will say that the initial momentum, I'll just represent it with P1. The initial momentum will be the product of mass and the initial velocity of the object, and the final momentum representing it with P2 will be equal to the product of mass and final velocity of that particular object, right? So initial momentum and final momentum may be represented as mu and mv, where we know that m is the mass of the object and u is the initial velocity, v is the final velocity. In this particular mathematical representation, we see that momentum depends on two factors. One is the mass and the other is the velocity. Fine. It depends on mass. More is the mass, more will be the momentum of the body. Similarly, it depends on velocity. More is the velocity, more will be the momentum of the body. Correct? Now, we know that the SI unit of mass is kilograms and the SI unit of velocity, whether it is initial velocity or final velocity, it is meters per second. Therefore, we can say that the standard international unit of momentum is kilogram meter per second. It also may be written as kilogram dot meter second inverse. This we already know that per second or divided by second can also be written as second inverse, right? Now, since in the formula we see that momentum is based on or dependent on mass and velocity, therefore we say that momentum has both the qualities, both the entities, like it has got both direction as well as magnitude. Because of the velocity, it has got direction also. Therefore, we can say that momentum is a vector quantity. What are vector quantities? We have already studied previously. Those quantities which have got magnitude as well as direction, they are known as vector quantities, right? Now, we know that we have studied earlier, the application of an unbalanced force brings a change in the velocity of the object, right? If we are applying any unbalanced force, then either a stationary object will start moving, or we may change the velocity of the object by making it slower or faster by applying, or just applying force in the same direction or in the opposite direction, or we can also stop a moving object. So, by applying unbalanced force, a change in the velocity of the object can be achieved. Therefore, we can conclude that force also produces a change of momentum. Why? Because by applying force, we know that the initial velocity and the final velocity, the values are changing. Clear? Right? Now, there is one thing that we concluded, that force produces change of momentum. Second thing, let us consider a situation in which a car with a dead battery is to be pushed along a straight road to give it a speed of 1 meter per second, which is sufficient to start its engine. Right? Now, if one or two persons give a sudden push or apply an unbalanced force on it, it will hardly start. But a continuous push over some time results in a gradual acceleration of the car to this particular speed. Therefore, from this particular thing, we conclude that it is not only the change of momentum and the force, important thing, the momentum of the car or the change of momentum of the car is also dependent on the time for which the force is exerted, right? Fine. So, change in momentum is related to the rate at which it is changed and the force which is being applied, and this is what gives the basis of Newton's second law of motion, right? First of all, what we have concluded is that the force necessary to change the momentum of an object depends on the time rate at which the momentum is changed, and based on this, Newton gave his second law of motion. Now, what did Newton say? Newton's second law of motion states, this is quite important, bache. Newton's second law states that the rate of change of momentum of an object, I repeat, the rate of change of momentum of an object is proportional to the applied unbalanced force in the direction of force. The rate of change in momentum of a particular object is proportional to the force applied. Got it? And when we are talking about the changing of velocity or changing of momentum, then we can easily relate that it must be an unbalanced force which is causing the change in the velocities. Got it?